Hi everyone. So in the last session, hi all. This is part 2 of weekly quiz 25 discussion. Okay, so we are discussing this weekly quiz 25. We have already seen the part 1. In part 1, we have discussed the question from 1 to 7. Now this is our question number 7. So 1 to 6. These questions we have discussed in this part 1. Now today we are going to discuss the part 2, means questions 7 to 15. These questions we will discuss in this session. Okay, so this is part 2 of weekly quiz 25. In this weekly quiz, the topic is finite automata and regular expression. This is the topic for this weekly quiz. So let's start. Let's solve this question number 7 in the weekly quiz 25. This is a very nice question. Please read this question. Let me tell you, this is a standard question, and this question is taken from Florida Institute of Technology, FIT. From this institute, this question has been taken. You can check it out. This same question we have taken from this FIT, from this university. So this is a very nice question. Now let's solve it. Let's solve this question. So first you read this question and you understand this question, then you solve the question. See, this question is very easy if you understand this question. Okay, so let's see. The question is saying that M is a DFA. So this is clear that M is a deterministic finite automata. We say that strings x comma y in sigma star are indistinguishable. Okay, we write like this, that x comma y are indistinguishable. So this symbol we use, because this indistinguishable, you can also say equivalent. Okay, indistinguishable, you can also call it equivalent. So that is the reason this symbol we are using. Okay, we are using this symbol for equivalent, or I can say this symbol we are using for indistinguishable. So we are saying that x comma y strings in sigma star, they are equivalent if and only if this happens. Can you tell me what this means? This equation, what it means? Can anyone tell me? See, the question is very simple. The question is saying that M is a DFA. This M, this is a DFA. This is a given DFA. Remember, this is a given DFA. Now the question is saying you have two strings x comma y. These are strings in sigma star. They can be any string. Remember, the question is saying that x is equivalent to y if and only if what happens? This equation is it true? X is equivalent to y if and only if this happens. Can anyone tell me what it means? This means sigma star delta star q0x that is same as delta star q0y. Can anyone tell me what it means? First of all, what delta star means and what this delta star q0x, what it means? Can anyone tell me? First of all, tell me about this. This delta star q0 comma w, what it means? First of all, this delta star, this is your extended transition function, right? This delta star, this is your extended transition function. This is the extended transition function. Okay, so this is your extended transition function. This q0, this is your initial state. This is your initial state of DFA. This is the initial state of DFA. Now, what this entire thing means, what it means when I write delta star q0 comma w, what this means? This is equal to the state where your DFA will go when you read string w. Yes or no? Remember, what is this delta star q0 comma w? This means that from state q0, this is your initial state. From state q0, when you read this string w, when you read this entire string w, okay, when you read this entire string w, then in which state you will go? In which state you are going to go? Okay, so remember this delta star q0 comma w, this is equal to q. This is equal to q. And what this state? This is the state where your DFA will go when you read string w. So remember, this is the state. So please understand that this is the state in which DFA ends, after consuming entire string w. after reading entire string W, after reading entire string W from the initial state, starting from the initial state, starting from initial state. Please tell me, is this clear? Let me know what this means. Is this point clear? What this means? So this delta star, this is your extended transition function. Okay, delta star Q0 comma W. This means from state Q0, when you read this string W, where you will go? From this state Q0, when you read this string W, in which state you will go? This is the meaning of this expression. Okay, now you tell me. So what it means? Now look at this equation. So remember, these two are same. What that means? These two are same. What that means? That means that from state Q0, from the initial state Q0, when you read X, from the initial state Q0, when you read X, you will go to some state. And when you read Y, then also you will go to the same state. Okay, is this point clear? So remember what this expression means. This equation, look at this equation, what it means. It means that from state Q0, okay, you are starting in the state Q0, from state Q0, when you read X, then you will go to some state. When you read Y, then you will go to some state, and those two states are same. These two states are same. So when you read X, you will go to some state. You read X, you will go to some state Q. That is same as when you read Y, then you will go to some state Q. These are same. So this is the meaning. Is this point clear? Very simple. So for all the strings, yes, we are starting in the initial state. We are always starting in the initial state. See this Q0. We are always starting in the initial state. So DFA will always start in the initial state. Is this point clear? Please tell me, is this understood? Let's take example. With example, this point will become more clear. But this is what I want to tell you, that in the question, please understand, in the question, this is given. In the question, they have defined a new thing. They have defined string equivalence. Okay, they have defined string equivalence defined in this question. String equivalence defined in this question. Defined in this question. What it means? In this question, it is defined. Okay, remember, this string equivalence is defined. It is defined in this question. In this question, it is defined. And the question is saying that you have X comma Y. These are strings. They can be any string, right? They are strings in sigma star. So they can be any string. They can be any string. They are strings in the sigma star. So they can be any string. Now the question is saying that we say X is equivalent to Y if and only if. We say X is equivalent to Y if and only if from the initial state of this DFA M. Remember, the DFA is already given to you. Already DFA M is given to you. This is already given to you. So from the initial state, when you read this string X and when you read this string Y, you will go to the same state. You will end in the same state. Okay, you are going to end in the same state. So then we will say, in this situation, we will say that X is equivalent to Y if this happens. Okay, so very simple. From the initial state, always from the initial state, X comma Y, if they go to same state, if they go to the same state in this DFA is already given to you. In this DFA, from initial state, if both these string X comma Y, if they end in this state Q, if they end in the same state, then we will say that they are equivalent. So this is the question that is given to you. Okay, very simple. Yes or no? Please tell me one thing. This definition of string equivalence, is this standard? This definition of string equivalence, is this standard? This is not standard. They have defined it. So please understand, in this question, they have defined. All you have to do, just analyze. See, this definition is given to you. They have defined it. They have defined. Okay, remember what they have done. They have defined. They have defined. You need to analyze. They have defined. You analyze. Okay, so this is the point. You need to analyze. They have already defined it. So they can define in some other way. Yes or no? In the GATE exam, if the question will come, maybe what they can do, they can define in some other way. Yes or no? Maybe they will not give you this question. Maybe they can give you some other definition. They can define the same, the string equivalence they can define in some different way. So this is what I'm saying, that they have defined in this question, the definition is given. You read this definition, you understand this definition, and you analyze. Then you solve the question. Now let's see some examples. In this DFA, look at this DFA. First of all, tell me, is this DFA? Look at this and tell me, is this a DFA? Yes, this is a DFA. So let's assume this is the given DFA. Let's assume this is the given DFA M. Okay, so let's assume this is your given DFA M. So this DFA M is already given to you. This is the given DFA M. Okay, you can see this is a DFA. Okay, this is your initial state. You can call it Q0. So here we have this initial state. Let's call it Q0. This is the initial state. You can see. Okay, and this is your, these two are final states. You can notice these states are final states. Let me call it Q1. Let me call it Q2, and let me call it Q3. So very simple. Now you tell me which strings are equivalent in this DFA. In this DFA, tell me, can I say these two strings AB, AAB, are they equivalent? Please tell me. Please tell me, these two states, are they equivalent? These two states are these two strings, are they equivalent? This string X, this string Y, are they equivalent? From the initial state, where your DFA will go when you read this string XAB, when you read this string AB, where DFA will go? From this state Q0, when you read AB, where you will go? When you read AB, you will go to Q3. And when you read AAB, where you will go? When you read AAB, from the initial state, when you read A, then B, then again you will go to Q3. So yes, they are equivalent. You can notice they are equivalent. These two strings are equivalent because from the initial state, this string is also going to Q3 and this string is also going to Q3. So I can say these two strings, they are equivalent. Okay. Now you tell me one more thing. Let me ask. What about these two strings? Are they equivalent? These two strings, are they equivalent? Please tell me. Are they equivalent? This is your string X. This is your string Y. Are they equivalent? Tell me. These two strings, they are not equivalent. They are not equivalent because from the initial state, if you read this string, you will go to state Q1. And if you read this string from the initial state, if you read this string, then you will go to state Q2. And they are different. So that is the reason these two strings are not equivalent. Let me tell you one mistake. One mistakes people will do. See, some students, what they will do, they will minimize this DFA. Let's assume in the exam, in the question, let's assume this DFA is given to you. So tell me, will you check on this DFA or will you minimize it? Tell me. If this DFA is given to you in the question, let's assume this DFA is given to you. In the question, this DFA, let's assume this DFA is given to you. Will you minimize this DFA first? Don't minimize. Check on this DFA. Please understand. Check on this DFA. If you minimize this DFA, then what will happen? See, this is a mistake, very common mistake. What people can do. If this DFA is given to you in the question, then some students, what they will do, they will minimize. First, they will minimize, then they will check. Okay, this is what they will do. Some students, they will first minimize, then they will check, then analyze. First, so tell me one thing. If you minimize this DFA on your screen, remember this is a mistake. So this is a mistake. This is a common mistake. So you tell me, if you minimize this DFA, then what will happen? Let's assume I minimize this DFA, then A, B, they will become equivalent, yes or no? See, if you minimize, then what will happen? You can easily notice that you can merge these two states. Q1, Q2, you can merge. So if you minimize, then you will get this DFA. You can merge Q1, Q2. These two states you can merge. Okay. So finally, you are going to get this DFA. This is the DFA you will get. Now you tell me. In this minimized DFA, this new DFA you are getting. So let's call this new DFA. Remember this new DFA you are getting. Let's call this new DFA N. Okay, so now you tell me, in this DFA, can I say A, B are equivalent? Can I say A, B are equivalent? Yes. String A, B are equivalent. Yes or no? In this new DFA, after minimization, you will get a new DFA. In this new DFA, these two strings are equivalent. But in the original DFA, what happens? A is not equivalent to B. Yes or no? In the original DFA, A is not equivalent to B. So tell me, did you understand this question? Did you understand the common mistake? This is a common mistake people will do. If this DFA is given in the question, then some students will minimize this. So don't minimize. Check on the given DFA. Okay? Check on the given DFA. Very simple. So anyway, we have seen that these two strings are not equivalent. What can you say about these two strings? For example, what about this string and this string? What about this string? This is your X and this is your Y. What about these two strings? What about these two? They are also not equivalent, because where DFA will go from the initial state on this string, where DFA will go from the initial state on this string, where DFA will go? DFA will go to Q0. Yes or no? DFA will go to Q0. And where DFA will go on this string? On this string, the DFA will go to Q3. So again, you can notice that these two strings, they are not equivalent. They are not equivalent. I hope this point is clear. I hope this point is clear. Tell me, okay, one more thing you tell me. So, okay, I think this is enough for this example. I hope you understood the question. The question you understood. I'm telling you, just I'm making you understand the question. Now let's assume that this is the given DFA. Now let's assume this is the given DFA M. Let's assume this is the given DFA M. Now you tell me, in this DFA, which two strings are equivalent and which strings are not equivalent? For example, in this DFA, you tell me about these two strings, A, B. Are they equivalent? Yes, they are equivalent, because from the initial state, what is your initial state? Your initial state is 6. Your initial state is this. This is the initial state. From this initial state, on this string, you will go to 7. And on this string also, you will go to 7. So I can say these two strings, they are equivalent. So very simple. Tell me about this one. What about this string? ABB, AAB. What about these two strings? ABB, AAB. What about these two? This is your string X. This is your string Y. Are they equivalent? Yes, again, they are equivalent. Again, they are equivalent, because you can notice that from the initial state, your initial state is 6. This is your initial state. From this initial state, on this string, you will go to state 9. And on this string also, you will go to state 9. So like this, you can easily see. What about these two strings? For example, this string AB and this string BABB. What about these two? Are they equivalent? These two strings, they are not equivalent. These two strings, they are not equivalent. Okay, because from the initial state, your initial state is 6. From the initial state, on this AB, you will go to state 8. And on this BABB, on this, you will go to state 9. Okay, so you can easily notice they are not equivalent. What about these two strings? ABB. What about this string and what about ABABBB? Okay, what about these two strings? These two strings, yes, they are equivalent. Yes, they are equivalent. Okay, so you understood the question. Okay, so can I say that you understood the question? The question is quite simple. I'm just telling you how to understand the question. Now let's see options one by one. Okay, so the question is quite simple. The question is saying that you have two strings X, Y. They can be any string from the sigma star. Now we will say they are equivalent if and only if from the initial state of the given DFA, a DFA will be given to you. From the initial state of this given DFA, the DFA will go to the same state on these two strings. Then we will say that these two strings are equivalent. Okay, you understood the question. Now let's check the options. So check the first option. Check the first option. The question is asking necessarily true. The question is asking, what the question is asking? The question is asking necessarily true. Necessarily. So the question is, the first option is, every pair of strings in LM are indistinguishable. Means every pair of strings are equivalent. Is this true? Is this true? Is this true? Necessarily true. Remember, the question is asking necessarily true. The question is asking what is necessarily true. So the option A is saying that every pair of strings in L of M. What is L of M? That is the language of given DFA. L of M, that is the language of given DFA. A DFA is given to you. So can I say every pair of strings are equivalent? Can you give me counter example for option A? Can anyone give me counter example for option A? I want counterexample for option A. Can you give me? Yes, there can be multiple final states. Very good. For example, you can say that option A is false. Option A is false. Why? You can easily give a counterexample. Consider this counterexample. For example, Q0 on A, you are going to state, let's assume you are going to state 1. On B, you are going to state 2. Let's assume this is also final. This is also final. Okay. So consider this. First of all, you tell me, is this DFA? On your screen, is this DFA? Yes, this is a DFA. Okay. So let's assume this is the given DFA M. Let's assume this is the given DFA M. Now you tell me, what is L of M? What is L of M here? Here, what is L of M? That is your sigma plus. That is your sigma plus. All the strings other than empty string. Every string other than empty string. You have all the strings which are not empty string. Okay, so that is your sigma plus. This is your language. You tell me, in this language, can I say every two strings are equivalent? For example, can I say AB? Remember, AB belongs to L of M. And remember, BA, that also belongs to L of M. Can I say they are equivalent? In this DFA, DFA is already given to you. In this DFA, can I say AB is equivalent to BA? No, they are not equivalent. They are not equivalent because from the initial state, on string AB, you will go to state 1. From the initial state, on string BA, you will go to state 2. So you can easily notice that in this DFA, if this is your DFA M, then you can easily notice these two strings, they belong to L of M. They belong to L of M, but they are not equivalent. They are not indistinguishable. Okay, so this is your counterexample for option A. Is this point clear? That option A, that is not necessarily true. Option A can be true, yes or no? Option A may or may not be true. Remember, option A, that is not necessarily true. Option A is not necessarily true. Option A, that is not necessarily true. Okay, this option A, this may or may not be true. But the point is, this is not necessarily true. For example, if the DFA has one final state, then can I say that this statement, this option A will be true? For example, if DFA has one state, on one final state only, let's assume you have this DFA. Okay, consider this DFA. Let's assume this is your DFA. Okay, let me assume. Now, this is your DFA, state 1, state 2. In this, you can notice that every two strings in LM, they are equivalent. Yes or no? Here you can notice for all x, y in LM, this is your DFA M. This is your DFA M. So you can easily notice that here for every two strings which are in the language, can I say they are equivalent? Every two strings in the language, they are equivalent. Yes or no? Yes or no? So here you can notice. So for this DFA, if this is your DFA, then for this DFA, I can say that every two strings in the language, remember your L of M, what is that? That is sigma plus. Here L of M, that is sigma plus. So every two strings are equivalent. But I have already given you one DFA where they are not equivalent. Let me give you another DFA. If this is your DFA, for example, consider this is your DFA. A, this is final state. B, this is final state. Then whatever comes, you go to dead state. So let's assume this is your DFA. Okay, I have given you a DFA. You tell me what is L of M. If this is your DFA, then what is L of M? Tell me what is L of M. So you can notice we are accepting string A. We are also accepting string AB. This is the language. Your language is A, AB. Yes or no? This is the language A, AB. This is the language. You tell me, are these two strings in the language, they are equivalent? Can I say these two strings are equivalent? A, AB, are they equivalent? They are not equivalent. Okay, these are the strings in the language. You can notice these are the strings in the language. This is the language. And in this language, these are the strings, but they are not equivalent. Is this minimal DFA? This DFA that is given to you, is this minimal DFA? Yes, this is minimal DFA. Yes, this is minimal DFA. So I have given you multiple examples. Notice this is minimal DFA. Still you can see that in this language, two strings, they are not equivalent. Yes or no? This is minimal DFA. Still you can notice that for this DFA, these two strings which are in the language, but they are not equivalent. And in this DFA, this is also minimal DFA. In this DFA, you can notice Whatever two strings you can take in the language, any two strings you take in the language, they will be equivalent. So the point is option A is not necessarily true. What about option B? What about option B? Option B is saying two different strings in LM are never indistinguishable, are never equivalent, are never equivalent. Is this true? Are never equivalent, never equivalent. This is also not necessarily true. Yes or no? Option B, that is also not necessarily true. That is also not necessarily true. Okay, option B, that is also false basically. I can say option B is also false, or I can say that that is not necessarily true. For example, can you give me a DFA? See, option B is saying that every two strings are two different strings in LM are never equivalent, are never equivalent, are never equivalent. But you can consider this DFA, you can consider A comma B, A comma B. This is the DFA you can consider. Okay, so let's take this DFA M. Now here you can notice what is happening. These are the strings in the language. For example, this belongs to L of M. For example, this also belongs to L of M. And you can also notice that they are equivalent. Yes or no? These two strings are equivalent. So I can say option B, that is not necessarily true. Is this point clear? Very simple. So option B is also false, because option B is saying that two different strings are never equivalent, are never equivalent. So this is a false. What about option C? What about option C? Indistinguishable relation on sigma star is equivalence relation. So what is equivalence relation? Tell me, what is the meaning of equivalence relation? Let's see. What is equivalence relation? So option C is saying that for equivalence relation, you need to check reflexive, symmetric, transitive. This we have seen in the discrete mathematics. In the discrete mathematics, we have seen what is equivalence relation. Equivalence relation. Equivalence relation means the relation must be reflexive, the relation must be symmetric, and the relation must be transitive. The relation must be transitive. So the relation must be reflexive and symmetric and transitive. This is equivalence relation. These two things should happen. What about partial order relation? What is that? What is partial order relation? Tell me. Partial order relation. That is reflexive, anti-symmetric, and transitive. Okay, this type of relation is called partial order relation. So the question is asking this indistinguishable relation, means your base set is what? The question is asking this equivalence. Indistinguishable means equivalent. Indistinguishable. This is a complicated word. Yes or no? This is a confusing word, right? This is a confusing word. So you can just simply call it equivalent. You can simply call it equivalent. Okay, so just call it equivalent. Now, what you can say, the question is asking this equivalent relation. This is the relation that is defined on the sigma star. What is the base set? Read this. Tell me, what is the base set? See, what is the base set? The base set is on strings in sigma star. On sigma star. Sigma star is the base set. Please understand, sigma star is the base set. On sigma star, this relation is defined. This equivalent relation is defined. So remember, your base set is a sigma star. This is your base set. Your base set is sigma star. And the question has defined this relation. This relation, this is the relation that is defined. Okay, this is the relation defined on, this is the relation that is defined on sigma star. So remember, this is the relation from sigma star to sigma star, I can say. Okay, I can say this is a relation from sigma star to sigma star. Means string of sigma star, they will be related to strings of sigma star. And this is the given relation. This is your indistinguishable relation. Indistinguishable relation. So this is your relation that is given. Okay, so this is from sigma star to sigma star, means strings of sigma star, they will be related to strings of sigma star. Okay, now you tell me, can I say, let's assume a DFA is already given to you. So let's assume there is a DFA that is given to you, given DFA M. Okay, let's assume this is some DFA is given to you. I want to ask, is this relation, is this reflexive? Is this reflexive? This relation is this reflexive? You tell me. Can I say two strings? Can I say any string W is equivalent to W? Can I say any string W that is equivalent to W? Reflexive means, can I say every string is related to itself? Reflexive, what that means? Reflexive means, can I say every string is equivalent to itself? Can I say this? That whatever string you take for all W, whatever string you take, can I say that that will be equivalent to itself? Yes, because what will happen? See, this is a DFA, right? This is a DFA. So what will happen? From the initial state, on W, you are going to some state. On W, you are going to some state. So on W, you are going to state Q. Then on W, you are going to state Q. Yes or no? Agree or not, right? See, this is very simple. On W, you are going to state Q. So on this W also, you will go to state Q because they are same. Okay, so I can say that every string W is equivalent to itself. Every string W, this will happen for all strings W. Every string W will be equivalent to itself. Okay, this will happen for all strings. Now, you tell me the next. Is this symmetric? This relation, second question. This relation is defined. This relation is defined in the question. I want to ask you, is this symmetric? This relation that is defined, is this symmetric? Symmetric, what this symmetric means? Symmetric means that, what it means, first of all, what it means? It means that if X is equivalent to Y, then can I say Y is equivalent to X? Okay, this is the meaning. If X is equivalent to Y, then can I say Y is equivalent to X? Yes, of course. So this will be symmetric also. This will be symmetric also because notice, if X is related to Y, if X is equivalent to Y, then Y also will be equivalent to X, because if X is equivalent to Y, what I can say? I can say that on X you are going to state Q, on Y you are going to state Q. So from here I can say that Y is also equivalent to Q. Y is also equivalent to Q, because what this means, they are going to same state. Okay, what this means? If X is equivalent to Y, it means they are going to same state. So I can say Y is also equivalent to X. Very simple, because they are going to same state. Okay, X comma Y, they are going to same state. So very simple. So this is symmetric also. What about transitive? What can you say about transitive? Please tell me. What can I say about transitive? Can I say this relation is transitive? First of all, what transitive means? Transitive means that if X is equivalent to Y and Y is equivalent to Z. Okay, if X is equivalent to Y, and Y is equivalent to Z, then X should also be equivalent to Z. Okay, this is the point. So you tell me, is this transitive? Yes, this will be transitive also. Because if X is equivalent to Y and Y is equivalent to Z, what it means? Tell me what it means. If X is equivalent to Y, Y is equivalent to Z, what it means? Remember, X is equivalent to Y, then it means from the initial state, on X you will go to some state, on Y you will go to same state. This is the meaning. Okay, this is what it means. Yes or no? X is equivalent to Y, it means that on X comma Y you are going to same state. On X comma Y you are going to same state. What it means? What this means? This means on Y comma Z you are going to same state. On Y comma Z, where Y is going, Z is also going. Where Y is going, Z is also going. So can I say X comma Z are going to same state? Can I say X comma Z, they are going to same state? Can I say X comma Z? Can I say X comma Z, they are going to same state? Yes, they are going to same state. So I can say X is equivalent to Z. So this is transitive also. Okay, yes or no? This is a transitive also. Very simple. See, the logic is very simple. If X is equivalent to Y, Y is equivalent to Z, what it means? It means on X comma Y you are going to same state. On X comma Y, on these two strings you are going to same state. So let's assume you are going to state Q. What this means? This means on Y comma Z you are going to same state. So on Z also, you are going to this state Q. So can you notice that on X comma Z, you are going to same state. On X comma Z, you are going to same state. So they are also equivalent. So this is transitive also. So is this point clear? So this relation that is given to you in the question, this relation is given to you. Is this antisymmetric? The last question, is this antisymmetric? This relation that is given to you, is this antisymmetric? Is this antisymmetric? See, antisymmetric, what it means? What antisymmetric means? Antisymmetric means that if two different people you take, what antisymmetric means? Antisymmetric means that if two different strings you take, if you take two different strings, then this cannot happen. X is equivalent to Y and Y is equivalent to Z. This cannot happen. This cannot happen. This cannot happen. Okay, this is the definition of antisymmetric. Please understand, this is the definition of antisymmetric, that if you take two different strings, if you take two different strings, then this cannot happen, that X is equivalent to Y and Y is equivalent to X. This cannot happen. So tell me, this relation that is given to you, is this antisymmetric? This is not antisymmetric. Why? For example, you can take this X. You can easily notice that I can give you some DFA, I can give you. Okay, I can give you some DFA. Or you can easily notice that if X is equivalent to Y, then Y is also equivalent to X. Okay, for example, okay, maybe you can consider this DFA. State 1 on A comma B, you are going to this state. Let's assume this is final state, you are A comma B. This is your state 2. Can you notice that these two strings, AB, comma, ABA, are they different? These two strings, are they different? Tell me. AB, comma, ABA, are they different? Yes, they are different. These two strings are different. This string, they are different. But can you notice that AB is equivalent to ABA and ABA is equivalent to AB? Okay, so you can notice they are different. These two strings are different. They are different strings. But still you can notice that AB is equivalent to ABA and ABA is equivalent to AB. So this relation is not antisymmetric. So finally, I can say this relation is definitely what? Tell me. This relation is definitely equivalence relation. This relation is reflexive, symmetric, transitive. So these three, that means equivalence relation. So this is a equivalence relation. Okay, is this point clear? So this is your complete analysis of this question. So finally, I can say what is necessarily true? Option C is necessarily true. Option C, that is necessarily true. Please tell me, did you understand this question? This is a very nice question. And this is a simple question, can I say? Can I say that this is a simple question? Tell me. See, if you read this question, some DFA is given to you. M is a DFA. This definition is given to you. You need to understand this definition. Just understand what this means. Understand what this means. And then you solve. First, you understand what this means, and then you solve. So this is quite simple question, if you notice. Okay, so I can say what is necessarily true? The answer will be option C. So the answer, that will be option C. Option C, that will be the answer. Okay. Now let's move on. Let's move on now. Let's solve this question. Let's solve this question. Question number 7. This is similar to question number. Sorry, this question we have already seen, right? This question we have done. Okay, this question number 7, this question we have already done. Now let's see this question number 8. Let's see question number 8 in this weekly quiz 25. This is similar to question number 7. Yes or no? The same definition. The same definition. This is similar to question number 7. In the question number 7, we have already seen what this means. What this means, that we have already seen. We have already seen. Okay, so now this is, I can say, you just need to analyze these options. Okay, so let's analyze. So tell me, the first option is saying that what is necessarily true? The first option is saying if X comma Y are equivalent, then XA, Y are also equivalent for every alphabet symbol A. Is this true? Is this true? Tell me. If x comma y are equivalent, see option A, what this is saying? This is saying that if x is equivalent to y, then xa will be equivalent to ya for every a belonging to sigma. For every a belonging to sigma, for every alphabet symbol, for every alphabet symbol. So is this true? Is this true? How can you prove it? Yes, this statement is actually true, but how can you prove it? See this option A, this is actually true. Let's see the proof. The proof is also quite simple. First of all, you tell me what this means. First of all, what this means. If x is equivalent to y, what this means? First of all, you tell me what this means. This means that from the initial state, remember some DFA is given to you. Remember some DFA is given to you. So let's assume some DFA M is given to you. Okay, some DFA M that is given. Some DFA is given. In the question, some DFA is given. Some DFA that is already given to you. M is a DFA. So this is already given to you. Okay, now let's see. So tell me what this means. X comma y are equivalent. This means that from the initial state, on x comma y, you are going to same state. On x, on y, you are going to same state. Now you tell me one thing. Now you tell me one thing. From the initial state, on x you are going to q, on y you are going to q. Now, where you will, all you need to do, just read one more symbol. Agree with me? Do you agree with me that you just need to read one more symbol? Okay, so tell me, on A, if you read this symbol A, this can be any symbol in the sigma. Okay, this can be any alphabet symbol in the sigma. Whatever alphabet symbol you take, then you will go to some other state. Now you tell me, can I say on XA, on YA, you are going to same state? Can I say on XA, on YA, you are going to same state? From the initial state. From the initial state, on XA, on YA, you are going to same state? Yes. So I can say they are equivalent. Yes or no? Is this point clear? Is this point clear? So I can say XA, YA, they are equivalent. So very simple proof. So this is your proof. I hope this point is clear. Tell me, did you understand this? This proof, did you understand? Very simple proof. Because x is already equivalent to y, it means you are going to same state. On x, on y, you are going to same state. All you need to do from this state q, you just need to read one more symbol. Whatever alphabet symbol you take, whatever alphabet symbol you take, you just need to read one more symbol. If you read this symbol, you will go to some state. You will go to some state q2. Now you can notice that on XA, you are going to state q2. On YA, you are going to state q2. So they are equivalent. So this is your true. This statement is true. Option A, that is necessarily true. What about option B? What about option B? If string XA, YA are equivalent, then can I say x comma y are also equivalent? Tell me. If string XA, YA are equivalent, then can I say x comma y are also equivalent? For example, consider this. Not actually, consider this DFA. For example, let's assume this is your given DFA M. Let's assume this is your given DFA M. Now on this DFA, you tell me, look at option B. What option B is saying? Option B, what option B is saying? Option B is saying that if XA is equivalent to YA, if XA is equivalent to YA, then X is equivalent to Y. This statement is actually false. Let me tell you, this statement is actually false. Can you notice in this, what you can do? In this DFA, you can notice that AB is equivalent to, can I say AB is equivalent to BA? Can I say AB is equivalent to BB? Notice. Can I say AB is equivalent to BB? Tell me. Can I say in this DFA, AB is equivalent to BB? So here, what you can assume, let's assume this is X, this is Y. Okay, let's assume this is X, this is Y. Okay, so can you notice that XB is equivalent to YB? Or you can, for simplicity, you can take A, no problem. You can see that this AA, BA, they are equivalent. A, BA, they are equivalent because they are going to same state. Now what you can assume? You can assume that this A is X and this B is Y. Okay, so you can notice that this is true. XA is equivalent to YA. Yes or no? Yes or no? If you assume that X is A, Y is B, if you assume X is A, Y is B, then you can notice XA is equivalent to YA. But what will happen? Tell me. But can I say X is equivalent to Y? But tell me, X is equivalent to Y. Can I say X is equivalent to Y? This is your X, this is your Y, but they are not equivalent. They are not equivalent. Is this understood? Please tell me. Is this point clear? So very simple thing. So remember, this option B is false. Okay, so please understand the difference between option A and option B. See, option A is saying that if on X comma Y you are going to same state. Okay, this is what option A is saying. Option A, that is saying that on X, on Y, if you are going to same state, then further also you will go to same state, right? Agree or not? Yes or no? See, option A is saying that on X comma Y, if you are going to same state, let's assume this is you and this is your friend. Okay, let's assume this is you and this is your friend. This is your friend. Now you meet in this is Delhi. Okay, you meet in Delhi. Now you tell me. Okay, so tell me now. If you meet in Delhi, then further you will go together. Yes or no? Further you are going to go together. Agree? So if X is equivalent to Y, on X comma Y, if you meet in same state, on X comma Y, if you go to same state, then further you will go to same state. Yes or no? Okay, then further also you will go to same state. Agree? Is this point clear? This is what option A is saying. But what option B is saying? Option B is saying that from the initial state, if you are coming on X comma A, this is some X. Okay, on X comma A, if you are going to same state, on XA, YA, then does it mean that on X comma Y you are going to same state? Tell me. See, option B is saying what option B? Option B is saying that if on XA and YA they are going to same state, XA comma YA they are going to same state, XA YA they are going to same state, then can I say is it guaranteed that X comma Y they will go to same state? Is it guaranteed that X comma Y will go to same state? No. Maybe this is going to some state here, maybe this is going to some state here, right? Yes or no? They can go to different states. Maybe on X you are going to state 1, on Y you are going to state 2. Please tell me, is this point clear? So very simple. So you can note this option B, this is a false. So option B is false. Is this intuitive? Are you understanding these diagrams that I'm creating? These diagrams, the diagram explanation. Intuition, are you getting the intuition what is happening? Now let's see. So you can see option B, that is a false. What about option C? Now option C is saying that if X comma Y are equivalent, then XW, YW are also equivalent, whatever string W you take. Okay, so this is similar to option A. In option A, we are attaching only, see, in option A, what we are doing? Notice this option C. What this option C is saying? This option C is saying that if this string is equivalent to this string, then XW will also be equivalent to YW, where W is a string. What is the difference between option A and option C? Tell me, what is the difference between option A and option C? Is there any difference? Yes, there is a difference. In option A, we have if XY are equivalent, then XA is equivalent to YA. We are only checking alphabet symbol. Okay, in option A, we are attaching alphabet symbol. Means only one symbol we are attaching. In option A, we are attaching only one symbol, only one alphabet symbol. Yes or no? Is this point clear? So remember, in option A, we are attaching only one alphabet symbol. But in option C, what we are doing? We are attaching a string. In option C, we are attaching a string. Attaching any string W. Okay, so you tell me, this option C, is this true? This option C, yes, this is true. The same explanation. See, if x comma y are equivalent, what this means? What this means? If x comma y are equivalent, what this means? This means that from the initial state on x, on y, you are going to same state. You are going to same state. Remember, we are talking about DFA. We are talking about DFA. Some DFA is given to you. Some DFA is given to you. Okay. So on x comma y, you are going to same state. Now you tell me, on x, on y, you are going to same state. Now this state Q, it will go to some state on W. On W, it will go to some state. Yes or no? On W, it will go to some state. Correct? Now tell me, can I say that on XW, on YW, I am going to same state? On XW, on YW, I am going to same state. On XW, I am going to Q3. On YW, I am going to Q3. So yes, on XW, on YW, I am going to same state. So they are also equivalent. So this is your option C. So option C is actually true. Okay, option C is actually true. That is true. And this is your proof. Very simple. What is option D? What is option D? Option D is saying that this is similar to option B. Option D is saying that if XW is equivalent to YW, then can I say X is equivalent to Y? Tell me. Tell me. This option D, is this true? Option D, is this true? This is false. This is false. Okay. Similar to option B. Similar to option B. Similar to option B, this is also false. Okay. Very simple. Because option D is saying that if XW, YW, they are equivalent, means from the initial state, on XW, you are going here. On XW, you are going here. On YW, you are going to the same state, right? Yes or no? Agree? On XW, on YW, you are going to same state. From the initial state, on XW, you are going to state Q. On YW, you are going to state Q. Does it mean on X, Y, you will go to same state? Tell me. Tell me, does it mean that on X, Y, you will go to same state? No, it does not mean. For example, maybe on X, you are going to state 1. On Y, you are going to state 2. Yes or no? You can notice on X, on Y, you are going to different states. You are going to different states. So you can notice that if XW, YW are going to same state, it does not mean that X, Y are going to same state. So similar to option B, this option D is also false. So finally, what is your answer? Tell me. So I can say this is also false. Option C is correct. So your answer will be, for this question, the answer will be A, C. This will be correct answer. Tell me, did you understand this question? We have done the complete analysis of this question. Question number 7, 8, they are basically same question, similar question. Question number 7, question number 8, they are same question, only options are changed. So we have done the complete analysis of this question. Now let's move on. Now let's solve this question, question number 9 in this weekly quiz 25. Let's solve this. What this question is saying, give a deterministic finite automata with the least number of states. What this means? We need to find out minimal DFA. Minimal DFA. Yes or no? Minimal DFA we need to find out. The question is saying this language is given. Strings. W is a string. The number of A's in W is even if and only if the number of B's is even. This IFF, this means if and only if. What is the number of states in the DFA? What is the number of states in the DFA? Let me tell you, this is a standard question from Redboard University. This question is taken from Redboard University. You can check. This question as it is, we have taken. So this is a very nice question. Let's solve it. So did you understand the question? This language is given to you. The language is saying the number of A's in W is even. This will happen. Okay, this will happen if and only if. If and only if this will happen, if and only if this will happen. Okay, and remember IFF means if and only if. Now you tell me one thing, this if and only if P if and only if Q, when this is true, P if and only if Q, when it is true, when it will be true, tell me. When it will be true? It will be true when either both P comma Q are false, either both P comma Q are false, or both P comma Q are true. Yes or no? Either both P comma Q are false or both P comma Q are true. Is this point clear? Let me know. This we have seen in the propositional logic. Yes or no? In the propositional logic, we have already seen this. In the propositional logic, this P if and only if Q. This means P if and only if Q. P if and only if Q. Biconditional. Biconditional. So you can notice when this will be true. This will be true when both P comma Q are same. P comma Q, they both can be false or they both can be true. Yes or no? Is this point clear? Please tell me. So here in this question, you can notice this is if and only if. This is if and only if. So I can say that this is, let's call it P. Let's call it Q. So you have P if and only if Q. This is what you have. P if and only if Q. So tell me, which strings you have in this language? In this language, which strings you have? So this language is given to you. In this you have strings over A comma B. The alphabet is A comma B. So you have those strings where number of age is even. Number of age even if and only if number of B is even. This is the language that is given to you. So tell me one thing. You tell me one thing. For this string, let me give you some strings and you tell me these strings, are they in the language L? Let me give you some strings. For example, consider this string A, B, A, B. This string, does it belong to L? This string, does it belong to L? Yes, this belongs to L. Why? Because for this string, this statement is true. Correct? See, this entire statement, let's call it statement S. Let's call it statement S. So tell me, for this string, statement S is true or not? For this string, statement S, that is true. That is true, because you can easily notice. Okay, let's assume this is P. Let's assume this is P, and let's assume this is Q. So you can notice for this string, what is P? Tell me. For this string, what is P? P is true. P is true. And what is Q? Q is also true. Okay, yes or no? For this string, P is also true. Number of A is even, that is true. Number of B is even, that is also true. So P is true, Q is true. So that is the reason I can say this P if and only if Q. Is this true? Is this true? Yes, this is also true. Yes or no? So I can say for this string, the statement S is true. Please tell me, did you understand? Tell me, did you understand? Yes or no? Now you tell me the next. For example, let me give you this string now, AB. Consider this string AB. Does it belong to L? This string AB, this string, does it belong to L? This also belongs to L. This also belongs to L. Tell me why? Because for this string also statement S is true. This entire statement is true for this string also. For this string, this entire statement is true. Why? Tell me, for this string, what is P and what is Q? Tell me. For this string, what is P, what is Q? For this string, see, P is false, yes or no? For this string, P is false, agree? Because in this string, number of A is odd. Number of A is odd. So for this string, this P is false. And number of B is odd. In this string, number of B is odd. Number of B is odd. So this Q is also false. You tell me one thing. False if and only false. That is true, right? Yes or no? False if and only false. That is true. See, this we already know that true if and only if true, that is a true. True if and only if true, that is true. Similarly, false if and only if false, that is also true. Okay, that is also true. What about this? True if and only false. What about this? False if and only if true. What about these? They are false. They are false. Okay, so very simple. Now you tell me here, can you notice that this string also belongs to the language? Yes or no? Is this point clear? So this string also belongs to the language. So please understand that in this language, you have this string AB also, you have this string AB also. Okay. Now what about this string? For example, A double B. What about this string? Does it belong to L? This string A double B. This does not belong to L. This string does not belong to L. For this string, statement S is false. Statement S is false. Why? Why statement S is false? Tell me, what is P for this string? For this string, what is P? See, P is saying number of A should be even, but number of A is odd. In this string, number of A is odd. So P is false. And what is Q? Q is saying number of B should be even. In this string, number of B is even. So this is true. False if and only if true. False if and only if true. That is false. Yes or no? So I can say that for this string, this condition is false. This condition is false. So this string does not belong to L. Finally, what about this string? Tell me, what about this string? Does it belong to L? This string, this also does not belong to L. Because for this string also, you can notice this statement S is false. For this string also, this statement S is false. For this string, what is P? For this string, P is true. For this string, Q is false. True if and only false, that is false. So remember, for this string, this condition is false. This condition is false. So this string does not belong to L. Did you understand this language? Please tell me. Please tell me, did you understand this language? See, this is a standard question from the Redboard University. Okay, so this is a standard question. Please tell me, did you understand this language? This language, did you understand? So which strings you have, which strings you don't have in this language? Can you give me the conclusion? Can you give me the conclusion which strings are there in this language? So remember, this statement, when this will be true? This statement will be true in two conditions. This statement will be true in two conditions. What are those true? What are those conditions? This statement will be true in two conditions. What are those? One condition is number of A even and number of B even. Yes or no? This is one condition. Means this is also true, this is also true. Okay. This is also true, this is also true. True if and only if true, that is true. Okay, so this is the point. True if and only if true. This is a true. So I can say that when this is also true, this is also true, then string will belong to the language. And when both are false, then also string will belong to the language. Yes or no? False if and only if false. This is also true. So if both are false, this is also false, this is also false, then also string will belong to the language. So remember, when this will be false, tell me when this will be false. When number of A is odd. And when this will be false, when number of B is odd. So in these two conditions, please understand, in these two conditions, I can say these are the two conditions. This is the condition number 1 and this is the condition number 2. In these two conditions, I can say that string will belong to the language. So string will belong to the language when this happens or this happens. Okay, so this type of strings you have. For example, AB will belong to L. AB will belong to L. ABA will not belong to L. AAB will not belong to L. So I hope this point is clear. Now, if you understood this, can you tell me, what can I say about the entire string? When this will happen? See, either this happens or this happens. Either this happens or this happens. Okay, one of them happens. One of them happens. See, very simple. Either this happens or this happens. Okay, so now you tell me. When will one of them will happen? See, in this situation also, the entire string will have even length. Yes or no? In this situation, entire string has even length. In this situation also, entire string has even length. Correct or not? See what I'm saying. Very simple point. I'm saying that number of A even, number of A even, and number of B even. Number of B even. In this situation, what your string length will be? What your string length? Number of A even, number of B even. In these situations, what your string length will be? String length. Tell me the string length. Means length of string W. Okay. So you tell me, in this situation, number of A even, number of B even. I want to ask, what are the string length? So when number of A even and number of B even, when both are even, then this string length will be even. And what about this? When number of A is odd and number of B odd, then string length will be even. What about this? When number of A even and number of B odd, what about this? Please tell me. And number of B odd. What about this situation? And when number of A even and number of B odd, number of A odd, number of B even, number of A odd, number of B even. So you can notice that in this situation, the string length will be odd. In this situation, the string length will be odd. Okay, is this point clear? So can you notice something interesting? Something interesting. We are interested in these, yes or no? These strings are in the language. Can you notice? Can you notice these strings belong to our language? These strings belong to our language, yes or no? These strings belong to our language. These strings are in language L8. These are in our language. So can I simply say that we have strings of even length? Can I simply say that we have strings of even length in the language? In our language, we have strings of even length. So can I say that our language is this? Our language is this. Our language is this. This is our final language. Please tell me, did you understand? Let me know. This is your final language. This is your final language. Even length strings. This is your final language. In this language, you have all and only even length strings. All and only even length strings. Now you can create the DFA. Now can you create the DFA for this language? Now you can quite easily create the DFA. So tell me, what will be the DFA? Minimal DFA. We want even number of strings, even length. We want even length strings. We want even length strings. So in the initial state will be final or not? Initial state will be final or not? Yes, because empty string length is 0. That is even. Empty string length is even. Okay, empty string length is 0. 0 is even. So I can say initial state will be final. If symbol A or B comes, then you will go to odd length. Okay, if symbol A or B comes, you will go to odd length. If another symbol A or B comes, you will go to even length. This is your final DFA. So minimal DFA has how many states? Minimal DFA has how many states? Only 2 states. Minimal DFA has only 2 states. This is your final answer, that minimal DFA has only 2 states. This is a quite interesting question. Please tell me, did you understand? This is a very interesting question, right? Any of you found this question interesting? See, many students, they will say, for this question, remember, for this question, many students will answer 4. Did you answer 4 in the weekly quiz? For this question, many students will answer 4. Did you give this answer 4? Did you give this answer 4? So for this question, I can say the answer will be 2. This will be the answer. But for this question, many students have given answer 4. Many students have given answer 4. Okay. So this is quite a simple question. This is a standard question. I want to tell you that first understand the language. This is the thing that I want to tell you. I want to tell you, first understand the language before solving the question. This I told you many times, right? In our lectures, I told you many times. Do you agree with me? First, understand the language. Before solving the question, first understand the question. First, understand the language. First, you understand the language, then you solve the question. Then solve question. This I told you many times in our lectures. Okay, so this is very important. First, understand the language. Which strings are in the language, which strings are not in the language. What this means? When I say understand the language, what it means? Tell me. When I say understand the language, what it means? This understand the language. This means you just check which strings are in the language, which strings are not in the language. Yes or no? You check which strings. Find out which strings are in the language, which strings are not in the language. So find out which strings belong to the language and which strings don't belong to the language. Is this point clear? So this I told you many times, that first you understand the language, then you solve the question. Okay, so first you find out which strings belong to the language and which strings don't belong to the language. First you do this, then you solve the question. So we have done this. Please tell me, did you understand? Now let's see the next question. Question number 10. Question number 10. This is similar to the previous question. Question number 9, question number 10, they are similar. Question number 9, question number 10, they are similar. Okay, so you can solve this question also. Yes or no? This question also you can solve. The answer will be 2. The answer will be 2. Tell me what will be the language in this question. Question number 9, question number 10, they will have the same language. This is also a standard question from this Red Board University. From this Red Board University. Let me tell you, this question and the previous question, they are basically same. In the previous question, what we have? See, in the previous question, we have number of A even if and only if number of B even. See, please understand that in the question number 9, in question number 9, what we have, and in question number 10, what we have. In question number 9, we have number of A even if and only if number of B even. And in question number 10, we have number of A odd if and only if number of B odd. You tell me one thing, these two, are they giving you the same language? See, this question number 9, question number 10, will they give you the same language? Will they give you the same language? Yes, they will give you the same language. You can notice that they will give you the same language. These two statements, this statement, they are basically same. These two statements are same. If you remember, see, P in the propositional logic, we have seen this. This statement is same as P bar by conditional Q. Do you remember? Do you remember in propositional logic, we have seen this? In propositional logic, we have seen this. In propositional logic. Anyone remembers? In propositional logic, we have already seen this. That this statement, P by conditional Q, that is same as P bar by conditional Q bar. P bar by conditional Q bar. This P if and only if Q, that is same as P bar if and only if Q bar. These two statements are same. In propositional logic, we have seen. So anyway, you can just check. You can just analyze this question number 9, question number 10. They have the same language. You can analyze. They have the same language. They have the same language. And what is that? That is set of all even length strings. That is set of all even length strings. So remember, here also you will get the even length strings. You can check. Here also you will get even length strings, and here also you are getting the even length strings. So ultimately you are getting even length strings. Okay, is this point clear? Can I create variation? Can I create some variation? What variation is possible? What variation is possible? Variation 1, variation 2. See, these are the variations possible. For example, I can say Here you can put odd, and here you can put even. See, these are the variations possible. Now tell me what will be the language. Tell me. So now you can notice that these two variations, they will give you the same language. These two, they will give you same language. They will give you same language, and that language will be odd length strings. That will be odd length strings. Okay. So this will be your language, odd length strings. So what will be number of states in the minimal DFA? What will be number of states in the minimal DFA? In the minimal DFA will have two states. For this, minimal DFA has two states. It will also have two states. Okay. So I hope this point is clear. So quite simple. We have done this. So tell me what will be the answer here. Here also the answer will be 2. This will be the answer. So this is your question number 10. Question number 9, question number 10, they are similar. They are question number 9, question number 10. They are very similar to each other. Let's move on. Tell me the answer for this question. Tell me. This question, this is your question number 11 in weekly quiz 25. This question is also taken from Redboard University. So this is the question taken. You can see standard question. So now tell me the answer. The question is saying, if for a language L, it is given that L star is L, then what does not necessarily follow? What does not necessarily follow? The question is saying L star is equal to L. L star is equal to L. Can anyone give me language for which this will happen? L star is equal to L. Can anyone give me such language? Can anyone give me such language? For which languages this statement will be true? For example, can I say for this language? Can I say for this language this will happen? For this language, can I say? No, for this it will not happen. Because remember, phi star is a set containing empty string, and that is not same as phi. That is not same as phi. What about this? What about this? Tell me, what about this? Yes, for this it will happen. Okay, you tell me what about this sigma star? For this also it will happen, right? Yes or no? For this also it will happen, correct? What about this? What about even length strings? L is even length strings. L is even length strings. What will happen for this? Even length strings. For this also it will happen. For this also it will happen. Okay, are you getting my point? Are you getting the idea? So you can notice this will happen for these languages. What about this language? Will it happen for this language? A, ABA. Will it happen for this language? L star is equal to L. Will it happen for this language? No, this will not happen for this language. Okay, very simple. You tell me. So the question is asking for L, what this question is saying? This question is saying that for L, it is already given. For L, already it is given that L star is equal to L. Then what can you say about L? Then what can we say about L? Then what can we say about L? Then what can we say about L? The first option, C. Then what can we say about L? You tell me about this. Can I say empty string will definitely belong to L? Can I say? Can I say empty string will definitely belong to L? Can I say empty string will definitely belong to L? So remember, L star is equal to L. Then can I say empty string will definitely belong to L? Yes. Yes. Yes or no? Option B. Look at option B. Option B is saying empty string belongs to L. See, this will definitely happen. What can we say about L? So I can say that this will definitely happen. Why? Why? Because what is L? See, L is equal to L star. L is equal to L star. And L star contains empty string, right? Yes or no? L star contains empty string. So L also contains empty string. Is this point clear? Notice that, see, it is given that L is equal to L star. It is given. This is given to you. So this L is equal to L star. And what is L star? L star is L power 0, union L power 1, union L power 2, and so on. And what is this L power 0? This is set containing empty string. So can you notice that this L will definitely contain empty string? This L is same as L star, and L star definitely contains empty string. So I can say that L also contains empty string. Yes or no? So definitely I can say empty string will definitely belong to L. This will definitely happen. This will definitely happen. But what the question is asking, see, this will definitely happen. But the question is asking which does not happen. Yes or no? Which may not happen. See, this will definitely happen. Please understand. This will definitely happen. But the question is asking which may not happen. Which may not happen. So this will not be the answer. Yes or no? Option B will not be the answer. Because the question is asking which may not happen. Okay, so here I can say this option B will not be the answer. What about this option A? Can I say LL is equal to L? Can I say LL that will be equal to L? Please tell me. Can I say LL will be equal to L? Let me know. How can you say LL? This will also definitely happen. This will also definitely happen. Why? Tell me. LL equal to L. See, option A. Option A is saying that LL that will be equal to L. How can you prove that this will definitely happen? How can you say that this will definitely happen? How can you say? How can you say this will definitely happen? Yes, one idea is proved by contradiction. One idea that is proved by contradiction. That is one idea. If this does not happen, then this will also not happen. This will also not happen. Okay, so one idea is proved by contradiction. One idea you can try that is proved by contradiction. That is proved by contradiction. Because notice. Already it is given that L star is equal to L. This L that is same as L star. And L star is L power 0, union L power 1, union L power 2, union L power 3, and so on. You tell me, if they are different, if this L and L square, if they are different, then what it means? There is at least one string in one of them, but not in the other. Yes or no? If they are different, then there is at least one string. There is at least one string which belongs to one of them, but not to the other. So if that string belongs to L square, then that will belong to L star also. Then this will not happen. And if that string belongs to L, then that will belong to L star. Okay, how to prove it? That LL is equal to L. How to prove it? There should be some simple explanation for this. This will definitely happen. LL equal to L, this will definitely happen. But how to prove it? There should be a simple explanation for this. L is equal to L star. Okay. So yes. See, it is already given that L is equal to L star, right? It is already given. It is already given to you that L is equal to L star. You tell me one thing. I just want to ask you one thing. That is, What is L star L star? This we have seen in the homework. In the homework we have seen this. What is L star L star? Tell me. What is L star L star? That is same as L star. Do you remember this we have seen in the homework? If you remember, in the homework we have seen that L star, if you again do star, that will be same as L star. This will also happen in the regular expression. In the regular expression also this happens. R star whole star, that is R star. Okay, this happens in the regular expression also. Agree? Yes or no? L star, if you do star any number of times, if you do star any number of times, that will be same as L star. And the same thing happens in the regular expression also. So if you remember, L star, that will be same as L star. Okay, now you tell me, L star, that is same as L star. Okay, that is same as L star. And L star is same as L. 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 So I can say LL, that is same as L star is same as L. So can I say that they are equal? So this is very easy proof. Did you understand this? Please tell me. So this was not complicated. This was quite easy. You can prove it like this. Please tell me, did you understand the proof? So very simple. See, we already know L star, that is equal to L star. This we already know. This we have seen in our lecture, in our homework. In our homework, we have already seen this. Also, we have seen L star whole star is same as L star. This also we have seen. This also we have seen. We have also seen that for regular expression, R star whole star, that will be same as R star. All these things we have seen in our lectures. In our homework, we have seen this. So you already know that L star will be same as L star. So you can notice, this is same as L. This is same as L. That is already given. It is already given that this is same as L. This is same as L. So I can say that LL will be same as L. So this is your simple proof. So I can say this will also definitely happen. So I can say that this option A, that will definitely happen. Means if this happens, then what can you say? If this happens, then I can say LL will be same as L. Okay, then I can say LL will be same as L. Very simple. Okay, so I can say that these two things actually they will follow. I can say these two things they will definitely follow. They will definitely follow. Okay, what about this one? L is infinite. Can I say L will definitely be infinite? Can I say L will definitely be infinite? Can I say? No, this is, see, can you give me counter example? This may not follow. This may not follow. Can you give me counter example? For example, this may not, for example, L is equal to set containing empty string. Set containing empty string. Set containing empty string. So this may not follow. So I can say answer will be option C. Answer will be option C. What about this? L is non-empty. Can I say definitely L will be non-empty? Can I say L will be definitely non-empty? Yes, this will definitely happen. Yes, this will definitely follow. This will definitely happen. Okay, because if you have empty language, if L is empty, then L star will not be same as L. Yes or no? If L is empty language, then L star will not be equal to L. So I can say L is definitely not empty. So I can say answer will be option C. Did you understand this question? Please tell me. Did you understand the question and the explanation? So you can notice, if this happens, if L star is equal to L, remember, if this happens, then definitely what I can say? Then I can say that L will definitely be non-empty. Then L will definitely be non-empty. Okay, L will be non-empty. Also, L contains lambda. L will definitely contain lambda. Also, LL will be same as L. All these things will happen. All these things will happen. One interesting variation I want to ask. This will happen for how many finite languages this can happen? Tell me. other than, this is my question. My question is, please understand my question. Question is, other than this language, other than this language, give me a language, give me a finite language for this will happen. Other than this, give a finite language, give a finite language L for which L star will be same as L. Can you give me? Can you try? Think about it. Other than this language, don't give me this language. Of course, for this language, L star will be same as L. For this language, L star will be same as L. But other than this language, can you give me a finite language? Can you give me finite language for which L star will be same as L? Tell me. Can you try? Not possible. Finite language I am asking. Satyam is giving A star. I am asking finite language. Finite language I am asking. Give me a finite language. Give me finite language other than this, for which L star will be same as L. The answer is not possible. The answer is not possible. The answer will be not possible. Can you prove it? Can you prove it? The answer will be not possible. Can you prove it? Can you prove it? See, let me prove it. Basically, our target. What is our target? We want finite language L. We want finite language L for which L star is same as L. Yes or no? This is what we want. Finite language for which L star is equal to L. Now you tell me, will this language work? Let's check. Will this language work? Tell me, will this language work? This language will not work. This language will not work, right? Okay. See, this language will work. This language will work. But we want other than this. Okay, this language will work. For this language, L star will be same as L. But we want other than this. But we want a finite language other than this. We want a finite language other than this. Okay, yes or no? So we don't want this. We want other than this. Now you tell me, other than these two languages, okay, so these two languages, other than these two languages, you tell me, see, this language will not work. This language will not work. L equal to 5 will not work. L equal to this language will work. Set containing empty string. This will work. This will work. I know this will work. This will work. But we want other than this. What we want? We want finite language other than this. This will not work. This will not work. Okay. Now you tell me, other than these two languages, if you take any language, can I say it will contain some string of length? See, notice, if I take some other language, then can I say there will be a maximum length string? Let's assume this is a finite language. Let's assume this is a finite language. If this is a finite language, you tell me, if this is a finite language like W1, W2, W3, Wn, this is a finite language. You tell me, can I say one of them will have maximum length? Can I say there is a string with maximum length? Can I say there is a string with maximum length? Please tell me. In a finite language, you have a finite language, then there is a string with maximum length. For example, consider this language A, AA, AB. What is the maximum length string here? What is the maximum length string here? What is the maximum length string here? That is A, AB. But the point is, we have some string of maximum length. These are the maximum length strings. This also. But the point is, we have maximum length string. So if you have a finite language, then I can say there is some string with maximum length. There is some string with maximum length. With maximum length. Let's assume that maximum length is L. Let's assume that maximum length, that is L. Okay. Now you tell me where I'm going with it. And tell me. This L is not phi, this L is not this, other than this. So what can you say about L? What can you say about L? Tell me. What can you say about L? Remember, L is not phi. Okay. I am already saying that L is not phi. L is not phi. Also, L is not this. So what can you say about this maximum length string? Tell me. In this language, this maximum length string, that will definitely have length greater than equal to 1. Yes or no? The maximum length string that will have length greater than equal to 1. For example, remember, if I give you, for example, consider this language also. Here, what is the maximum length string in this language? In this language, what is your L? Your L is equal to 5. Here the L is equal to 5. Yes or no? Is this point clear? So this is what I'm saying. So can I say that in this language there is some string. Let's assume that string is W. There is some string W with maximum length, and that length is greater than equal to 1. Now you tell me. Now you tell me. So this is the point. See, this is the point. You have a finite language L. Your finite language L other than phi, comma this. Other than phi, comma this. You have a finite language L other than these. Okay. So in this language, definitely what will happen? In this language, you have finite number of strings, W1, W2. Okay. You have finite number of strings, Wn. These are the strings. But the point is, there is some string. This string, let's assume this has the largest maximum length. Let's assume this is your maximum length string. There can be more than this. Okay, yes or no? Multiple. There can be multiple. Agree with me? There can be multiple. But I am saying that this is one of maximum length strings. This is one of maximum length strings. So its length, let's call it L, and that will be greater than equal to 1. This is the point. Now you tell me what will happen in L star. Now tell me what will happen in L star. Now tell me. So in this language, you have these strings. Okay. Where this is your maximum length string. Max length string. This is your max length string. Okay. Max length. And that max length is L. That is L. And that is greater than equal to 1. Now you tell me what will happen in L star. Tell me. In L star. In L star, what will happen? See, in L star, you will have L square also. In L star, what will happen? For example, just focus on this L square. Can I say in this L square, definitely you will have WW? Can I say? Please tell me. Can I say in this L square, you will definitely have WW? So I can say in this L star, you have definitely WW. Okay. You tell me one thing. This, what is the length? Tell me, what is the length? Remember, in this L star, you definitely have WW. What is the length? The length is 2L. You tell me one thing. Is there any such string? This string, does it belong to L? This string, can it belong to L? This string, can it belong to L? Can this string belong to L? Why no? Why this string cannot belong to L? Tell me why. Tell me why this string cannot belong to L. My question is, can WW belong to L? The answer is no. But why? Because in L, maximum length is L. Because in this language L, because in this language L, maximum length is what? Maximum length is L. Is this point clear? Did you understand the proof? So can this string belong to L? The answer is no. This string cannot belong to L. This string cannot belong to L because in this language L, the maximum length was L. The maximum length was L. So finally, so we have proven what we have proven. So we have proven that definitely L is not same as L star. Yes or no? Because L star contains this string. L star contains this string. L star contains this string. Remember, in L star, you have this string whose length is 2L. Whose length is 2L. But you can notice this string does not belong to L. So this string does not belong to L, but this string belongs to L star. So I can say that L is not same as L star. Did you understand the proof? Please tell me. So remember, this is never possible. Remember this point, that please understand this point, that only finite language, the only finite language for which L star will be L. What is that? The only finite language for which L is equal to L star. What is that? The only finite language for which L equal to L star is L equal to set containing empty string. This is the only finite language for which this will happen. Please tell me, did you understand the proof? See, the proof is actually quite intuitive. See, the proof is not complicated, let me tell you. The proof is quite simple, that if you take any finite language, in the finite language, there will be a maximum length string. Yes or no? See, the proof is not very hard. The proof is not very hard. The proof is quite simple, that if you take a finite language L, there will be a maximum length string. Agree? There will be some maximum length string. There will be a maximum length string. But this is the maximum length string. Whose length? This is maximum length string whose length is greater than equal to 1. Whose length is greater than equal to 1. Now, if you notice, now from here you can easily notice that L star will contain WW. L star will also contain WWW. Yes or no? L star will contain WW. L star will also contain WWW, and so on. But these strings are not in L. You can easily notice this string, they don't belong to L, because in this language L, the maximum length was this W. This was the maximum length. So definitely these strings, these strings, they don't belong to L. Okay, so that is the reason. This string, they don't belong to L. So that is the reason L is not same as L star. So L is not same as L star. Okay, so that is the reason. Finally, this is the conclusion. This is the final conclusion, that the only finite language, one and only finite language for which L equal to L star, that is this. So this is a special language. Yes or no? One and only finite language. One and only finite language. One and only finite language for which L will be equal to L star is L equal to set containing empty string. So this is your final. This is the final note. Please tell me, did you understand the proof? Is there anyone here who can say that, yes, I understood the proof? The proof was quite simple. This is not complicated. If you think about it, the proof is quite simple. Did you understand the proof? Please tell me. The proof, did you understand? So very simple proof. Okay, so this is what we have done. So this question, in this question, remember, so this we have done the complete analysis of this question. In this question, if I create one more option, in the same question, if I create one more option, for example, what will necessarily follow? Okay, so let's assume what necessarily follows. Let's assume I ask you what necessarily follows. Okay, what will necessarily follow? Let me ask you this question. Basically, I am asking a variation. This variation I am asking. What necessarily follows? Okay, I give you another option. That another option is L is either L is not finite, either L is not finite, or L is equal to this. Now tell me, which of them will follow? Which will necessarily follow? See, this will necessarily follow, this will necessarily follow, this will necessarily follow, and this also will necessarily follow. Yes or no? These statements will necessarily follow. Here, actually, one more thing. In this statement, in this option C, if I say L is infinite or L is this, now tell me, now will it follow L is infinite or L is this? Now this is also correct. Now this is also correct. Is this point clear? Either L will be infinite or L will be equal to this. So quite simple. Now let's move on. So very simple. I can write it here. I can write it here. Let me write it. L equal to L star. This implies either L is infinite, or L is this. Okay. This implies either L is infinite or L is equal to this. So this is your final conclusion. Now let's move on. This is your question number 12. So I think this is enough for today. I am also tired now. Okay, so we can discuss 3 questions are remaining. Question number 12, question number 13, question number 4. 4 questions. 4 questions are remaining. So these questions we can discuss in the next session. Please tell me, did you understand everything in this session? In this session, did you understand everything? Please tell me. Some analysis we have done, some good questions we have solved. Okay, some very nice questions. There were tricky question. That question number 8, question number 9, that was a tricky question. Okay, so I hope you got to know something new. Okay, I hope. Did you learn something new in this session? Did you learn something new in this session? So please comment on this video also. This video I will put on the YouTube channel. So please let me know in the comments. Please put a comment. Let me know. Did you understand the analysis? Did you understand all these proof? How much did you understand? Please let me know. Okay. So thank you everyone. The remaining questions we will solve tomorrow. In the next session, we will solve the remaining questions. Okay. Thank you.